Hello, conference attendees. I'm Tony Nordby, a project engineer with Houston Engineering out of our Thief River Falls, Minnesota location. My presentation today will focus on the development, design, permitting, and ongoing construction efforts for a flood damage reduction project located in the Red Lake Watershed District, known as the Black River Impoundment Project. The Red Lake Watershed District is in northwestern Minnesota and is a sub-watershed to the Red River of the North. The Red Lake Watershed District is a 5,990 square mile drainage area, making it the largest watershed district within the Red River Basin. The red square on the map outlines the general project location within the watershed district boundary. As we zoom in closer on the project location, the retention site outlined in red is located approximately 5 miles south and 8 miles west of the city of Thief River Falls. The 16.9 square mile drainage area, as shown in black, will be diverted to the retention area from the design of approximately 12.5 miles of diversion ditch, as shown in yellow, to intercept flow that naturally flows westerly across country to the Black River. During flood conditions or large rainfall events, runoff from within the contributing drainage area will be stored until downstream flood conditions subside, and then metered back into the Black River at a controlled discharge through the proposed outlet structure and channel. After the 1997 flood on the Red River that devastated the cities of Grand Forks, North Dakota, and East Grand Forks, Minnesota, efforts were made up and down the valley to reduce peak flow along the Red River main stem by 20% during a flood event similar to that of the 1997 flood. This effort started with the Red River Basin Commission's Long-Term Flood Solutions Basin-Wide Flood Flow Reduction Strategy report. That report provided each tributary to the Red River a peak flow and volume reduction goal. The goal set forth for the Red Lake River at the USGS gauge in Crookston, Minnesota, is 35% peak flow reduction and 13% volume reduction. In 2013, the expanded distributed detention strategies throughout the valley were completed within each watershed to try and get a better understanding of how on the landscape can those peak flow and volume reduction goals be met. As part of the Red Lake Watershed District expanded distributed detention strategy, the Black River subwatershed was identified as a location that would contribute towards those goals. The Red Lake Watershed District started to investigate potential project ideas and options within the Black River subwatershed and identified 4 alternative retention site locations to further investigate. Due to landowner cooperation and storage capacity potential of the selected alternative, the project was moved forward with the Red Lake Watershed District Board appointing Houston Engineering to proceed with further engineering investigation of the selected alternative. Preliminary engineering and early environmental discussions with permitting agencies looked promising and favorable for the project, so the Red Lake Watershed District moved forward executing flowage easements and land acquisitions from the existing landowners for the project in June of 2017. The retention site is an earthen embankment with a total levee length of 3.1 miles. The embankment has a 12-foot top width, 5-to-1 interior side slope, which is the wet side of the embankment, and an exterior side slope of 4-to-1. The retention site is designed to release water from the concrete principal spillway, made of a 60-inch reinforced concrete pipe with a 2-way reinforced concrete riser. An auxiliary 500-foot earthen spillway is designed as a secondary outlet at an elevation of 1.5 feet above the principal spillway. The total gated storage on this project is 3,162 acre-feet, or approximately 3.5 inches of contributing runoff from the 16.9 square mile drainage area. This means that an average of 3.5 inches of runoff over the entire contributing drainage area can be held within the retention area without releasing any of that water downstream. The total gated plus ungated storage of the retention site is 4,064 acre-feet, or approximately 4.5 inches of contributing runoff. All the diversion ditches and outlet channel are designed for a 10-year rainfall event, providing the heavily agricultural area well-improved drainage. During the design of this project, hydraulic and hydrologic computer modeling was performed using Hydrologic Engineering Center's Hydrologic Modeling System, better known as HEC-HMS, and Hydrologic Engineering Center's River Analysis System, better known as HEC-RAS. This slide provides a summary of the hydraulic capabilities of the retention site for multiple synthetic rainfall events when the principal spillway gate is in the closed position and the reservoir is started empty. Let's pick on the 100-year rainfall events to review. For each of the 300-year rainfall events shown, contribution of rainfall varies from 6.2 inches to 8.8 inches of rainfall. The modeling shows that when the reservoir is empty and the gate is closed at the onset of these storms, all flow from the contributing drainage area would be captured within the site with no outflow from the retention area. The map here shows the max water surface elevations when the gate is closed and the reservoir starts empty for a range of 24-hour synthetic rainfall events, from the 5-year up to the 100-year event. The east edge of the red shading represents if water within the site was level with the top of the principal spillway riser. The east edge of the orange shading represents the max water surface elevation for the 100-year 24-hour event, which reiterates and shows that our principal spillway riser is above the max pool elevation for a 100-year event, and therefore we can store all those synthetic rainfall events within the impoundment without releasing any water. This project will provide flood damage reduction benefits downstream on not only the Black River, but the Red Lake River and also the Red River of the North. Here we can review the downstream peak flow reductions for a range of synthetic rainfall events over a 24-hour, 4-day, and 10-day storm duration. The first location shown is where the project outlet channel enters the Black River. In reviewing the 100-year events, we can see that this project will reduce the peak discharge at this location by approximately 24% for all durations. The second location shown is at the Black River confluence with the Red Lake River. In reviewing the 100-year event here, we can see that this project will reduce the peak discharge by approximately 5 to 7% for the modeled durations. Multiple permits were required for this large-scale project. Since the retention site is considered a significant hazard dam, a dam safety permit was required by the state's Department of Natural Resources. The Black River is also considered a public water course, so any work proposed at the project outlet into the Black River required a public waters works permit. Several wetlands were determined to be impacted throughout the project extents, requiring mitigation or avoidance. Permits were required through the United States Army Corps of Engineers and the state of Minnesota's Wetland Conservation Act. The process for these permits began in 2017 with delineation, determining impacts, mitigation plans, and potential design avoidance with the respective agencies. Determinations were finalized and permits granted in June 2020. Other permits necessary for the project were a county shoreland permit and a county highway department permit for work within the right-of-way, and the construction stormwater pollution prevention plan required by the Minnesota Pollution Control Agency. Some of you are likely wondering, how much does a project like this cost? The opinion of probable cost for this project is $8,883,000. This cost includes the project development, engineering, environmental, permitting, land acquisition, construction, and utility relocation costs. Land acquisition included fee title purchase and flow easements for the retention site, and permanent and temporary construction easements for the construction of the diversion ditches. With a favorable construction bid and perfect working conditions this past fall, the total overall expenditure should come in less than the anticipated opinion of probable cost. After multiple efforts failed to try secure 50% funding on the project through the state of Minnesota's Flood Damage Reduction Grant Assistance Program, the Red Lake Watershed District and the Red River Watershed Management Board decided to move ahead with the project and fund it locally. The Red River Watershed Management Board's contribution from their flood damage reduction funds is not to exceed $5,922,000, which is approximately 2/3 of the engineer's opinion of probable cost. The Red Lake Watershed District would then cover the remaining 1/3 of the cost at a maximum of $2,961,000. Other funds that will be allocated to this project include $78,000 from the Red River Watershed Management Board's Water Quality Base Funding Program, $36,975 from a 319 Small Watershed Focus Grant, a minimum of $64,000 from the Red Lake River One Watershed One Plan, and $119,327 from the Red River Basin Flood Damage Reduction Work Group. These funds total approximately $300,000, which will contribute to the total project cost. A water management district was established to assess the property owners receiving drainage benefits from the project upstream of the retention site. This funding will provide a funding source for future maintenance of the diversion ditches. This project was advertised for bids in late August 2020 and was awarded and provided a notice to proceed to R.J. Zavrel and Sons out of East Grand Forks, Minnesota on October 22, 2020. The final completion date of the contract for construction is set for August 31st, 2022. With great fall and early winter weather conditions, the contractor has made great progress on levee construction and the principal spillway structure, as shown in the pictures below. This drone footage begins in the very northwest corner of the retention site, with the dozer at the bottom of the screen stripping topsoil from the footprint of the levee. The next dozer is shown excavating a 50-foot wide subgrade area, which in this location is 3.5 feet below the topsoil stripping. This material is being pushed to the sides and will be incorporated back into the random fill areas of the levee. As the drone turns and starts heading southerly, we can see off-road trucks hauling borrow material to fill the excavated subgrade area and start building the levee system. As you can see, the off-road trucks are driving down the levee system with full loads, aiding in the compaction of the levee system. A dozer is also shown leveling the material being placed by the off-road trucks. At the top of the screen, we can see a tractor and disc working the levee. By disking each lift placed on the levee, a uniform bond between each lift is made. 8 self-propelled scrapers were used during construction of the levee on this project by the contractor. Here we can see one of those scrapers incorporating some of the subgrade material previously pushed to the side back into the random fill area of the levee. As we continue south along the west side of the levee construction, we see more equipment shaping and compacting the levee. Here we can see that the levee has already been constructed several feet above the adjacent natural ground. The construction in the interior ditch is also evident just left of the levee, as an interior ditch was designed along the interior of the levee to connect the upstream diversion ditches to the outlet structure in the southwest corner of the retention site. The borrow pit to the left was one of 4 created within the retention site for the construction of the levee system. The photos here show aerial footage from the northwest corner of the retention site. The top left picture is looking east at the levee along Pennington-Cassaw 3 as the levee is being final dressed with topsoil. The bottom right photo is looking south at the westerly side of the retention site as the levee is being finished prior to adding the finished topsoil. The next photos shown are taken above the principal spillway as the concrete riser is starting to be formed. In these photos, the concrete cradle that the 60-inch reinforced concrete pipe will sit on has already been poured upstream and downstream from the riser. The top left photo is an aerial view looking from the outlet end of the structure at the bottom of the picture to the inlet side at the top of the picture. The bottom right photo gives a side view showing the concrete boom truck preparing to provide concrete within the forms of the riser structure. The last aerial photo of construction activity shows progress being made on the excavation of the outlet channel entering the Black River. The picture is orientated looking east back towards the retention site in the distance. Since this photo was taken, a rock riprap structure has been installed at the outlet prior to entering the Black River. This structure will minimize erosion of the outlet channel and transfer of sediment downstream in the Black River. I want to thank you for listening to my presentation today on the Black River Impoundment Project. If you have any questions or would like to discuss this project in more detail, feel free to contact myself or Myron Jesme, the Red Lake Watershed District Administrator, at the contact information provided. Please check out the Houston Engineering virtual booth to learn more about other projects we are involved with, and enjoy the rest of the conference. Thank you.